Hey, I think we're all here. Is that right? YouTube says live, right? That's what that means? And there's an end stream button instead of a start stream button? Okay, so we must be here. It actually just briefly said I had an actual viewer. Like 5 seconds after the stream started. I only gave out 10 minutes notice, but then they left. So there you go. Easy come, easy go, eh? Maybe some bot that just watches every YouTube video for some reason. Probably not though. Probably it was. So we're gonna do day 16 today. Which we looked at briefly a while ago, and it's like it is a parsing task, where much of the, I don't know, people on the subreddit were like, gosh, these instructions are so complicated, and they're not simple, I agree, but I don't think they're too bad if you like think about them. So first of all, let me make sure I have chat visible. There we go. First of all, the input, let's actually go look at the input, is just a gigantic hex string. But we are intended to treat that hex string as merely a delivery mechanism for bits. We should interpret, the very first thing we're going to do is turn all the hex characters into bits. And it's actually, which is kind of annoying, saying, well, there might be leftover zeros at the end of the stream, and that's okay. Which is a little, because they're like, oh, it's being sent to you in hex, but you should just treat it as bits. And so if we wanted to send you like a 51-bit message, obviously that doesn't go into 4, and so you would have 3 excess bits left at the end, and there'll be zeros. Okay, whatever. And then the whole thing is about reading this bit stream as a series of nested packets, where packets have like headers that describe that describe their contents. The first 3 bits are a version encoded in a like totally normal format. That is to say, they're just an ordinary 3-bit integers, right? This means 6, for example. And this means 4. So the next 3 bits are the packet type ID. So packets can have various types, which affect how you should parse them. And packets with type 4 represent just like a number. So the binary number is padded with leading zeros until its length is a multiple of 4 bits. And then they do like the kind of UTF-8 thing where they send groups of 5 bits, where each group of 5 bits represents both 4 bits of the actual number and then 1 extra bit, which is the number over or not. So they've said here, this is a version 6 packet with a type ID of 4, which means it's a literal number. And so we look at these chunks of 5 bits. This is, the leading bit says this is not the last chunk, and this says its value is 7. This isn't the last chunk either, and these bytes are 14. And this says this is the last chunk, and it's a 5. So if we took 14 times 256, or no, wait, 7 times 256, plus 14 times 16 plus 5, we would get the answer, right? Let me just, we can do that in GCI, right? Just, I know we can read the text, but wouldn't it be nice to confirm that I understand how things are encoded? So here we are. If I said 256 times 7 plus 14 times 16 plus 5, we would get 2021. And indeed, that is the intended value for this example number. Packets that don't have a type ID of 4 represent an operator. So in some way, this is a syntax tree being sent to us, right? We don't know what the operators are. In part 2, they'll explain that, but I assume they're like add, multiply, or like here's you know, parse a packet and right. Operators contain one or more packets, and we have to understand how that part works. We don't have to understand the specific details of any of the actual operators. So to determine which subsequent binary data represents its subpackets, the operator packet uses one of 2 modes, like a little thing. There's 1 bit right after the packet header, which recall is the 6 bits indicating a type and an ID and a type. And then there's the length type, which if it's 0, then there's 10 bits indicating the length in bits of all the subpackets. 15 bits. And if the length type is 1, then the next 11 bits tells you how many subpackets to parse. Yeah, so this is okay. And then, after the length type ID bit and the 15 or 11 bit field, the subpackets appear. But I think this is perfectly understandable if you think about it a little. And what our goal is to parse the hierarchy of all the packets and then just add up their version. So we'll have to build a tree, and each packet, recall, has a version number and a type ID is what it's called, type ID. Yeah, packet type ID. So those are the first 6 bits of every packet. The version number apparently doesn't mean anything, except that part 1 wants you to confirm that you've parsed the stream correctly by giving you all the packet numbers, or version numbers. Okay, so, I mean, this seems like the kind of thing that Parsec ought to be fairly good at. I had some fantasies the other day of, like, it would be kind of interesting to build our own little parser combinator library for handling these things, and I did actually like rebuild a parser combinator library from scratch last year for one of the puzzles, because Parsec didn't like to backtrack by default, and I didn't want to figure out one of the popular libraries that did. So, and it was not a regular language, so I couldn't use regular expressions. So I built a parser combinator library, and we could do that. But I think Parsec should be totally up to the task. Also of note, like if you're into Haskell, Parsec is like old and busted, but you know, these days people use Mega Parsec or Atto Parsec. I think Mega is the popular one now. But so far, like, I've never really encountered any of the problems that, you know, professionals say are the reasons they avoid Parsec and use Mega Parsec. Like, it's faster, I guess. But you know, I'm just old. Like, Parsec is fine. I don't do anything serious. I think there are some other issues with Parsec, but none of them have ever bothered me. If they do, I can try it. Mega Parsec. I understand they're basically the same, but with a few little tweaks, API-wise. Okay, so let us there's the input, and I assume it's all one line. Is that correct? Yes. Okay. So here we are. And we need, like, to do some things. What should we do? Excuse me. Just need some water, I guess. I don't know if we should start on, like, you know, reading the input. I don't know, probably not. If we were like absolutely mental, a thing that we could do is just write a Parsec parser that reads the hexadecimal characters, digits, let's say, and immediately transforms that like directly into the output packet type. But I think that's insane. Just a little bit of pre-processing to turn the hexadecimal digits into binary digits, and then writing a Parsec parser that parses bits instead of parsing hexadecimal digits will make everything 100 times easier. So we're going to do that. For which we first need data bit is 0 or 1. And I think, I mean, do we actually need eq, for example? Like, we could. But I don't think we really do. I'm gonna derive show. Maybe I'll end up needing eq at some point. Because, like, Parsec, I'm actually gonna have to open the docs on Parsec. I don't remember what anything is called. Parsec. So like character parsing isn't, I don't need that, we're not parsing characters. But if we were doing character parsing, which is what people usually do, or often anyway, there's somewhere in here, you know, something like digit or character, which parses a character and gives you back the character. We don't really want that. Actually, now that I'm thinking about it, why would we need eq? Oh no, right. Because our input isn't character at all. So we could have Parsec parse the characters, parse the ones and zeros, turn them into bits or whatever. But I kind of just like want to pre-process the stream into actual bits so that the parser is like total. Well, I don't know, it'd be total anyway. But where is, what do I want? Like in parser combinators, I think like this is kind of where choice count between, there's one in here somewhere that's like a primitive or something, isn't there? That's like if it's equal to this. No? I thought there would be. It doesn't matter, we don't need it. I just, I'm trying to remember how any of this stuff works. Prim? Maybe it's prim. Nope, this is not what I need. Token, yeah, alright. Alright, whatever. So we'll just we'll just get back to it. So we have we have a bunch of bits. Import text parsec, I guess, is what we want, right? Yeah, and that'll probably have much of what we need. What else do we need? We need a, well, let's find a few new types. New type, version ID is a version ID of int. Deriving, let's say, show and num, so we can add them together. Okay. You know what? Let's make it integer. I happen to see on the subreddit that, I mean, I don't know. We can always fix it later, but I saw on the subreddit some people were like overflowing their ints, and I assumed they were using like 32-bit. I think they were using like JavaScript floats or something. I'm using ints, whatever. I don't need. There's Eric never makes us go above 64 bits, and that's what we have in int. So okay. So we have a version ID. We have a new type. Packet type is a version ID of int. Sorry, it's a packet type of int. Deriving again, show enum. What else do we want? There's a new type. Length type is either bit length or num packets, we'll say, I guess. And we'll just give this show. I think that's, well, you know what? Let's also just new type literal is a literal of int, deriving also show and enum. So these are kind of the primitive types of which packets are made up, out of which. How do you avoid ending that sentence with preposition? Out of which packets are made is fine. I guess this is like the Winston Churchill thing, right? Was he the one who supposedly said the sort of English up with which I will not put? I guess this is the sort of primitives up with which packets are made. Up of which packets are made. God, English is stupid. Nobody would actually say that, but it's just like an example of the absurd. Why the rule that you shouldn't end sentences with prepositions is kind of absurd. Anyway, so these are the primitives that we're going to be building packets out of, right? And then presumably something more. Yeah, I was just thinking about the difference between part 1 and part 2. Because in part 1, we're going to parse the packet stream and wind up with packets that contain just strings of bits because we don't understand how to use them yet, right? It'll be an operator packet whose like payload is drug, like. Let me review. So there's an operator. Let's see if we can learn a little bit more about how operators are. So I don't know. It's actually kind of interesting because there's not any room inside of an operator packet for bits we don't know anything about yet. We just get like subpackets, basically, right? There's not any extra bits in there that we don't know anything about. So I guess that the point in the part 2 is going to reveal, you know, oh, an operator, by the way, you should look at its first value, which will be a literal or something, and, you know, if the literal is 7, it means multiply. If the literal is 9, it means add, or something like that, right? The point is that the structure that we have for a packet is going to be the same across part 1 and part 2. I was thinking at first that it would be different because we would learn more about how to parse packets in part 2, which we sort of do. But really, I think we just learn more about how to interpret packets. We'll be parsing to the same... the same data structure in part 1 and part 2. We'll just do a different kind of processing on it in part 2. The reason I was thinking about this is I was thinking, like, okay, I want to define data packet equals, something, right? And I was thinking, how can I make it general enough to handle both part 1 and part 2? In part 2, we're going to know more, is what I was thinking. But I realized that's not actually true. And so I was thinking, okay, we can get a packet of A where it contains, like, we parameterize by the data that goes into the unknown parts, where in part 1 it's just a list of bit, and in part 2 it's like something more detailed. But actually, I don't think that's true. I think we just have a single packet type, and we're going to write one parser and then 2 folds that fold over the packet stream, or packet tree, I guess. And there may be a temptation. Okay, well, okay. So how do we write a packet, right? Packet is there's a few things we could do. One is we could say it's a literal packet of literal, or it's an operator packet of list of packet, right? This seems like at first glance, kind of a reasonable thing to do. And maybe that's all the information that we'll need. Because we parsed out, like, all the lengths delimiting where the packets start and end and so on. And okay, I guess we need the version ID somewhere here, right? Wait a minute, I forgot. Packet types are how it's going to determine what operators are, because those are the things we don't know anything about, right? Version type ID. Version with 4 is a literal. Every other type of packet with a type ID other than 4 is an operator that that indicates how to combine packets. Right. So we're not going to look into, like, the first packet and it'll be like a literal telling us what to do. We're going to look at the type ID to determine how to combine packets. Right. Got it. So so the point is, we certainly need at least the type ID in an operator. Well, in this. For a literal packet, we kind of know that the type ID is 4. But we need a version, right? At least. So let's say data version A is versioned of version ID and A. Packet contents, then we could say is this, and a data packet is a versioned packet contents. So this is like a plausible representation. I'm wondering if there's some reason we can't do this. Like this kind of throws away some information, like about, oh, how did you, like, what was the length ID? Was it, how did you parse the length out of this thing? And that might be something we would need in part 2. But I doubt it. Oh, right. This isn't finished, of course. We need an operator packet that contains a packet type and a list of packet, right? So I think these 8 types are rich enough to describe a packet. And in fact, it's only these 7 types. We use bit as an intermediate on the way to describing a tree of packets. We need to write a function, a parser, basically, from a stream of bits to a packet is the idea. I'm actually gonna have to take a little break here. I hope to be back in just a few minutes, but maybe it'll be a bit longer. Sorry, it's only... how long have I been going here? I don't know. Anyway, I gotta go. All right, be back in a bit. All right, we're back. Riveting live stream content, as always. So where am I? I can delete this now. So right, we were saying that these are the 7 types that I think we need to process to represent a packet, and we need to write a parser that that can turn a stream of bits into this. So let's do that. That's kind of the interesting part, and then later we'll write a function that turns a list of hexadecimal characters into a list of bits to be parsed. So we have to look up how do you parsec is my question. So parsers, we have a parsec T, but I don't need any other monad, so I'm just going to use a parsec of where identity is supplied. So I don't think I need tokens for anything weird. So run parser is kind of like, what is the difference between run parser and parse? Parsec. Oh, with no state. We can run parse. We don't need any state. Yeah. Okay. So let's define a couple more types here. Type parser of A is a parsec of unit. Oh wait, something. Parsec of, so S. What is S? S is my state? No, stream type S. All right, what? Oh, it's a list of bit, right? So I have to write that? Parsec of list of bit? Because normally I would write string there, right? I think. So what's the stream? All right. The stream, so right, parsec takes an S, which it uses the stream type. If S, M, and T is a stream, I think we're just supposed to write list of bit here, but I'm like, what is stream? Instances. Yes, a list of tokens is a stream containing tokens for any monad M. And our M, it has to be for any monad. Yeah, okay. So we're just gonna, it's a list of bit. A? No, unit A, because we don't have any state, right? Let me double check. I've already lost. Parsers. A parsec of S and U. S is your stream type and U is your state type. And our stream is a list of bit and our state is nothing. Okay. And for some reason I thought we were going to need more type aliases than that. I think I was just... I don't think there's any reason I need that. All right, let's define some simple functions, shall we? Well, one thing we need, which isn't even a parser, is a function from list of bit to int, right? So let's just define from binary is a function from list of bit to int. From binary. I forget. This is a. Does it make sense to make this a fold R or a fold L? I've written this a million times and I always forget. Every time you parse a new bit, you double the significance of what you previously had parsed and add them. Yes, you want to fold L. Fold L strict. I mean, not that it matters. Next bit 0, where next bit of ACK and 0 is 2 times ACK. Next bit of ACK and 1 is 2 times ACK plus 1. Now, you know, we could write a thing that's like bit to int, I guess, and then this would be like 2 times ACK plus the bit, I guess. Am I going to need that? Not really. I think this is the only time I really need. need to do this. I can't think of any other reasons I would need to treat a bit as a number, except for this function. So I'll just like inline that basically. Some other things we will need fairly shortly, I guess, are a function that takes a list of chunks. Oh, you know what might be interesting? What if I defined a a function that took exactly 3 bits, or a type that had exactly 3 bits, because we need that a couple times, and a type that takes exactly 5 bits, because we need that? Do I need that, or is that, like, dumb? Is that, like, kind of pointless? I guess we'll find out later. Yeah, I don't think I'm really gonna need those types. Okay, so let's just kind of like start writing a parser and like see what happens, I guess. Actually, first, does this all compile? That's kind of important, isn't it? No. Multiple declarations of version. Oh, it is a packet containing versioned packet content. Thank you, yes. A new type must have exactly 1 constructor. Yep, you're right, that should be a data. Can't make a derived instance of num literal, okay. Language generalize new type deriving. What? Can't have a derived instance of num literal. But I turned on generalized new type deriving. Did I do it wrong? You can derive num if it's a new type around int. And why is it only complaining on this line, on line 13? Why isn't it complaining here? Huh? Okay, it is complaining about all of them. Try generalized new type deriving. Did I like spell it wrong? Like what? Language. Oh, I spelled language wrong. Very funny. Import data list foldel strict. Okay, now it all compiles. Great. You know what? Let's commit it. Why not, right? Day 16 packet types. Okay. So let's define packet is a parser of packet. Easy, right? Well, I don't know. I'm starting at the top. I often start at the bottom for stuff like this. Bottom in terms of like what abstraction level we're looking at. But we'll just do it this way for now. So packet is probably like I could. What do we need? We need to get a version. I mean, I guess it's just packet of versioned packet contents, basically. Sure. So versioned is a function parser of A to parser of versioned A, right? Versioned P is versioned version ID P? P. And we haven't we haven't written these functions, but we'll get there. A version ID is kind of interesting, probably. Version ID is a parser for version ID. Version ID is just a parser for int, right? So it's versioned from binary over replicate M3-bit. Bit is a parser for bit. Bit is pretty simple. It's either it's 0 of. Hang on. How do I parse a token? Low level operations, many. How do I get a parser that just like parses one thing and succeeds, a single token? I don't need any weird chaining today. Many choice. Table. Token? No. Is it in combinators? No. Index? What if I look for any? God, I can't even look at the oh, here we go. Any token, any char. These are, well, maybe I want any token. Did I miss that? Any kind of token. Got it. So, oh, how weird. The T has to be showable? Huh. Okay, but so you have a stream. Okay, yeah. So any token, got it. So that's what we need. 2-bit, let's say, of any token where 2-bit of one. No, hang on. I already have bits. I've already parsed the bits. There you go. Stream already is bits. You know, I'm gonna actually bit is a parser for bit. Bit equals any token. We're just gonna give that a name. Ugh. Import control monad replicate m. Is that where it is, or is it in something else now? Okay. So 3 times parse an int, and then convert it to binary, and wrap that up in a. Oh, this should be version ID. There. So the only thing we haven't done yet, I think, is packet contents, right? Which obviously is like all the work. packet contents equals undefined. Does everything parse after we compile after we've done this? It does. Okay. Packet contents is a parser for packet contents. Easy enough. So this is kind of the exciting parser. It does a number of things, right? Packet contents equals do. Because this is kind of, well, one thing I was thinking about briefly was whether this actually is a regular language that we could parse with just text regex applicative. Not that I would want to, it sounds miserable. You know, I love writing in applicative style, but some of these things are going to get kind of complicated. So having a monad handy is nice. But it's not regular because there's a few. We care, in order to decide the structure of what we're parsing, we need to know the value of what we've already parsed, and that's the kind of thing you can't do with applicative. So anyway, the point is this is a place where you have to make kind of a decision, I think. We have to read a version ID. No. A packet type. I can't call it type because that's a keyword. Packet T. There you go. Hey, Rubik's. T is a packet type. You know what I should do, actually? I probably need to break this up. Well, no. Do I have eq on my packet types? I don't. Do I want it? I think I do. If t equals... Okay, I was about to write 4, but 4 sucks. We need a literal packet type, and we'll just put that in a where clause somewhere. Equals 4. There you go. So if if it is a literal, then we will return so packet contents, we'll return a literal packet. Oh, then literal packet, right? I don't need to know the type anymore at this point, right? I'm going to say parse a literal packet. And a literal packet is just, it doesn't have any like length indicators, right? It's just like you parse chunks. Okay. Else, operator packet of t, right? That seems okay. Actually, you know, I can do a bit better, can't I? I can say it's operator packet t over a little bit weird that I won't have a function here named operator packet that parses operator packets, but we'll say sub packets is a parser that produces that reads a length field and then parses sub packets. Oh, hey Rubik, since you're here, I think you mentioned you use megaparsec, right? One of those I still use like old parsec because I've never really paid much attention to why people say like you shouldn't use parsec anymore. You should use megaparsec. Do you want to give me the sales pitch? Like, I don't know. I guess I can just look it up online, but I'm lazy, and I'm probably just going to keep using parsec anyway. So if that bothers you, then don't bother. Okay, so literal packet is a thing we need now. Well, let's do packet type. That should be easy. Packet type is a parser for packet type. Packet type is pretty much the same as version ID. Oh. Yeah, we could share some logic between those two, couldn't we? 3 bits takes a function from int to a and returns a parser for a. Okay, yeah, that's about where I am too. I hear megaparsec is like faster and doesn't, but I don't really know why. And maybe it has a couple things you can do. Oh, I think, is it? I forget whether it's megaparsec or attoparsec, but one of them in some contexts can automatically backtrack, but in other contexts it doesn't, whereas like in parsec it never backtracks. I don't know. It's a mystery. You don't need as many try operators with megaparsec, I think. So 3-bit of f is f from binary over replicate 3-bit. And then we can just say version ID is 3 bits interpreted as a version ID. And this is 3-bit interpreted as a packet type, right? Maybe I'm confused then, because I know parsec also never backtracks, and I thought one of the competing parser libraries had a feature where it sometimes backtracks. Maybe that one's attoparsec. I don't know. Cool. So these all type check, which is nice. And that seems. It comes from packet type. Now, why are you highlighting this? I spell it wrong? This packet type is not in scope, but it's right there. Now it is. I don't know. HLS has just gotten confused. It's never going to know what packet type is ever again. Okay, literal packet, yes, I agree that isn't in scope. I haven't done that yet. And subpackets also not in scope. Let's see what THCI thinks. What actually doesn't compile? Just these two. So LSP in Emacs has not been good for me at all. It like does a little bit of stuff, but I'm basically just not using it. I'm just using interactive Haskell mode. It just like works for a little while and then it stops working, and I never find out why. So let's write literal packet. That ought to be fun, right? Literal packet is a parser for, I assume I have literal packet? No, wait. It's a, I don't have a type called literal packet, right? I have a type, I have literal packet literal. Okay, so what I really should do is say literal packet of this, and then parse a literal. It's a parser for int now, right? Yeah, that seems good. No, it's a parser for literal. I could wrap the literal constructor here, but I'm not going to. I think it's nice for literal to be typed as a literal parser. So this is kind of the first like interesting thing we have. Well, I don't know. This was kind of interesting. You mentioned literal packet type stopped highlighting literal packet type. Yeah, I don't think it ever was highlighting it, was it? The problem was I had... Oh. I think LSP was right. No, I'm confused. I thought it was having trouble with something called literal packet, but maybe I didn't. Maybe it's because I didn't have literal packet defined, and I just like thought I did. I don't know. It's confusing. So literal is kind of interesting, right? Let's just write it in do style and see like what happened. We kind of want to read many one prefixed chunks followed by a single zero prefixed chunk, right? Yes, I agree packet type was being highlighted. Your message said it stopped highlighting literal packet type, which I don't think was the problem. But yeah, I think you're right that there's one fewer thing being highlighted than before. So that's nice. So I guess let's just say, let's say a literal is many, sorry, most, I don't know, it's one continuation chunks is many chunk prefixed with one. Is that what I want to write? Last chunk prefixed with 0. And then I can just say pure. I'm not parsing anything anymore. To literal from binary cat no, concat isn't right, is it? So continuation chunks is you know what? I can call this prefix, suffix, and treat them equally if I write concat over this. So I've parsed many chunks, and then I've concatened them, so I have one large chunk. And then I have a small chunk. And then I can just say prefix, suffix, right? And what kind of annoys me about this function is that it actually, I wrote it in monadic style, but it could have been written applicatively. I could turn on applicative do if I really care about that. I don't know. It's much nicer to write this applicatively, let me tell you. Well, that bad? I guess we could write it applicatively, but it's so legible this way. I'm not going to go back and write it applicatively. And I think it's even correct. Wouldn't that be nice? We want chunks prefixed with to be part of literal. No one else is going to use it. But I think it's kind of nice to have it separate so I can test it if I want. So let's write that. Chunk prefixed with is a parser for list of bit. And okay, technically it's a parser for exactly 4 bits, but chunks prefixed with equals do? I don't think I need do, right? How in Parsec do you say a token equal to foo? Is that a thing you can do? Or do I have to do it with like applicative operators? I don't think you can do it. Like I have any token, and if you're using data.char, if you were using char parser, not followed by. I don't think you can do it. I think you have to like option, like there's all this choice. Yeah, I don't. And choice I think is just asum these days. Not followed by, look ahead. I mean, what else is there in this dang library? I always feel like it should be somewhere in like the combinators thing, but it doesn't seem to be. Token? Maybe it's a text parsec token. No, this is like the thing where you define, it like does precedence and everything for you. All right, whatever. We'll just do it applicatively, even if there's something smart you can do. Or it's not even it's like a monadic operation to make this decision, isn't it? Okay, fine. Do header is a bit. Oh, wait a minute. Okay. No, this is fine because if it's the wrong bit, it'll fail. I was thinking I need to put a try here, but I don't. If we consume this bit, then we can't go back, but that's okay because we don't want to. Let's guard that. Oh, hang on. It takes a bit and returns a parser bit. Expected header? Expected. Header equal expected, and then we say replicate m4 of bit, right? I think that's it. And we need guard as well now. Cool. Oh, look at that. A whole bunch of stuff isn't read anymore. So we just need subpackets. Is that right? It might be interesting to test this. Satisfy. Oh, is satisfy the thing you're looking for? Yeah, that does seem crazy. That is what I was looking for. S. Oh, sorry, you can't see it. Text parsec char. It's in a million things. Yeah, you're right. It is kind of crazy. Why is that? Oh, are you saying that because it works in megaparsec? Satisfy is like smarter? Interesting. Yeah, I agree. It's crazy, but you know, it's not a big deal. We can just write it ourselves. So what I think I might like to do now is define subpackets is a parser for list of packet, and subpackets is undefined. No instance for each bit. I knew it. I knew there might be a reason I would want it, but I said no. I'll just use case. Well, in this case, I don't. I don't happen to have that handy, so I have to give it each. Okay. Look at it. It highlighted this in red. It's just like LSP is just so crazy. Or the Emacs integration for it is, because I know it works great in VS Code. I actually have a passing acquaintance with the guy who implemented most of LSP Emacs, apparently. I went looking at the GitHub page a while ago, and I was deciding whether to use VS Code or Emacs, and I, like, know him from Clojure 10 years ago. Like, not very well, but, I don't know. He might recognize my name if I said hello. That. Okay, so what I wanted to do, right, was test this. Yeah, I mean, Parsec is like the obvious. Yeah, satisfy should do that obvious thing, and it's kind of crazy that it doesn't, and that it's special to chars. I agree. So, let's test a very simple. Well, wait a minute. It might be nice. Okay, what I wanted to do is like parse this packet, right? and confirm that I get out like a reasonable value, that I get 2021. But it's actually, I don't have anything that can, I can't just copy paste this in because I don't have any way to turn strings into bits yet. Stop. Okay. Right, I don't think I do. But okay, we want to write, I guess, anyway, something that turns hex characters into bits. So we can write that now, I guess. Hex to bits is a function from char to list a bit, which again really ought to be it ought to return exactly 4 bits, but we're not going to be picky here. Now, should I, like, I don't actually know the right way to do this. I can call like digit to int in like hex or something. I think that works. Digit to int, it takes hex digits as well, or no? Yeah, it recognizes hex digits, upper and lower case. So I can do that. And then I guess I need an int to bits. Like, what is there in data bit? Just out of curiosity. Data bit. Module data bit. Doesn't that exist somewhere? Data bits, here we go. So like, this isn't really what we want, I think. I don't know, maybe it is. Yeah, I guess this is fine. Finite bit size, okay. All right, so it doesn't have anything for doing something as stupid as what we're doing, but that's okay. Let's import data bit, I think is the function we're gonna need, and import data char digit to int. Hex to bits of C equals map. What's the type of int A? Oh my god, it's not. Rubik says digit will take any character, but is digit char only takes the 10 digits 0 to 9. Why do you need is digit char though? I wasn't planning to use that. Set bit, so test bit. I guess test bit is what I want. Okay. I don't want bit, I want test bit. Oh, and is it? It's data bits, not data bit. Okay. Test bit. N of 3, 2, 1, 0, where n equal O. I can just write it here. Digit to int of C, right? Match type bool with bit. Oh, right. As bit. Let's say bool to bit of this, where bool to bit of false equals 0, bool to bit of true equals 1. What is the error it's saying? Test bit is applied to too few arguments. Oh, this should be composed with. Thank you. No instance for num bit. What? Oh, not 0, 1. Okay, cool. So it's happy with that now. So if we test that in GHCI, hex 2 bits of C, 1100. Is that right? That's 12. Yes, that's correct. So I guess that means we can actually test our little 2021 thing, right? So let's. Okay, how do you run a parser? I know you can call parse, but that's not quite what I want. Because it'll return either. So how do I run parser? How do I find out, like, how do I run a parser and be okay with getting, like, with having leftover stuff at the end? Because if you run parser, it'll say, oh, there's extra junk left over, won't it? It's not returning the, I guess I'm thinking of, I'm thinking of textfrag explicative, which does have a way to say, like, first matching prefix versus, like, parse the whole string as 2 different functions. Parse test? Prints it to standard out? Okay, weird. All right, well, we'll just say there are many zeros at the end, and that's fine, I guess. So parse. Already forgotten what my parser is called. It doesn't error if there's junk left over? Well, that's nice. Kind of thought it would. Parse with packet, I guess, of test input. I know you can use empty string, but whatever. And it takes an S, which is our list of things. So we're gonna map cat or flat map or whatever you call it. What's our test input? It's this. And I called my function just a moment ago, hex 2 bits. Hex 2 bits. Parser. Okay, great. But at least it's well typed. That's nice. Yeah, concat map exists, but I don't know why I would ever call it when I have this. Like, I can never remember what that damn function is called because I want to call it map concat because in Clojure it's called mapcat. And I always be like, what's it called in Haskell? It's not called map concat because then it would make sense. It's called concat map. And by that time, I'm like, I could have just typed out the bind operator. Like, so I don't know. I've just never used concat map, and that's where I find my happiness. Well, okay, first, I guess did this come out okay? Looks all right. It's saying unknown parse error. I have no idea what that means. Oh, because it doesn't know. Yeah, closure is a JVM list. That was how I was introduced to functional programming. And I think there was at least 1 year where I did Advent of Code in Closure. I think 2015 I did it in Closure, and then I went back and did it in Haskell later to get a little bit more familiar with it. Don't quote me on that. I don't think it's even on GitHub, so it might as well not exist. Maybe it is. I don't know. So it looks like it parsed okay. 1101 is how it starts and ends with 3 zeros. That's what we expected. Oh, yeah, gosh, I can annotate. I've never actually done that. I've never actually annotated my parsers with, like, what it expected. When parsing chars, it's always been, like, good enough. I actually have no idea how to use... Okay. It behaves as parser P, but when parser P fails... Okay. I guess we can do that. And it's also called label if we want to use it prefix. So, all right. What exactly... label packet? Like, I don't think this is going to be very useful. Like, but this is the very simplest thing I can do. I can label it as I wanted a packet. Add language overloaded strings, I guess. Why though? It just wants a string, right? Oh, it goes the other way around. I'm supposed to label this with packet. So it added overloaded strings because it was using a string in a context where it expected a parser. And it was like, oh, well, you know, if you use overloaded strings, you could have a string be a parser. And I'm like, that's not really what I meant. So if I parse this, it'll say unknown input. So I guess I have to start annotating all my things to say, like, what failed to parse, basically. Label this. Like, I'm just going to keep doing this until it gives me a meaningful value, I guess. Line 1, column 1, unknown parse error. Like, what is wrong with you? Well, sure, we can label this as well, I guess. 3 bits. Label this with... I don't know what it even means to have a single parser be labeled with 3 things, because that's kind of what this is going to be, but... Oh, actually, let's not label this one, because we don't even know what we're trying to parse here. A version ID and then a P, each of which can be labeled. Are we getting anywhere? Is this useful? I don't even know. Unknown parse error. Yeah, there you go. That can't be a parse error, right? Because it's expecting something, right? Okay. How can it be at column 1? That's what bothers me. Okay, let's double check first, I guess. This is actually an entire packet, right? Version, type, and then like bits. Okay, so first thing I'm going to do is, instead of using packet, I'm going to say many bit. There you go. Still wrong. Okay, so it's not that there was trailing junk at the end that bothered it. Unknown parse error. Like, that is the worst. Because packet version ID is like the first thing we read. Like, shouldn't it be like either saying, oh, I couldn't parse the version ID, or like succeeding at least far enough to get past column 1? I mean, I don't think I need to label packet contents here at all. The things it's calling can all be... Oh, what is the order that label... It takes a parser and then a string. Okay. So we can say flip label literal. Flip label chunk. Like I'm out of ideas here. I've labeled everything, and they're all okay. I guess okay. So here's what I can do. I can start running smaller parsers on, and instead of trying to run my entire packet parser, I can run a parser for like version ID on the first thing, right? So parse version ID of 110. Oh, I have to say what do you mean not in scope? Oh, it's lowercase. Whoops. So it says that's 6. Okay, that's good. And if I parse a type ID of 100, what? Is it not called type ID? Oh, I called it packet type, didn't I? Packet type. I missed a comma. That's a packet type of 4. These are all good. And I guess what's left? I can parse a literal on... Okay, I guess I'm going to need to find something that turns a list of bits into a list of characters into a list of bits, because this is no longer a hexadecimal string. I don't want to type in like 15 ones and zeros. Char 2-bit is a char 2 single bit. Char 2-bit of 0 equals 0. I hate this function. Char to bit of 1 equals 1. Okay. And now, yes, of course, pattern's not matched. I'm not worried. What I want to do is parse with literal on the empty string of map char to bit of that. Unknown parse error. Okay, so that's exciting. We found the problem. It's this. We can't parse a literal out of these 15 bits for some reason. Let's confirm that we should have been able to. What does literal do? Chunk prefix with 1 and chunk prefix with 0. Okay, so let's let... I don't have to write let anymore. It's not 2018. Let's say lit is this. Why do that? I don't know. Let's parse I already lost my chunk prefixed with 1 of the empty list for input and 1 0 1 1 1. So this should be a literal of 7, or a list. So that's correct. And if I say with 0, it'll unknown parse error. So this, oh, I'm so dumb. This is the problem with satisfy. This guard is the issue, right? We consumed this bit, and then we said, hey, this is wrong. And then it couldn't move on. It said, oh, this guard failed for some reason. I don't know. And so what we want, I mean, I guess we can just wrap this with try, but we shouldn't have to. If we had satisfy, we could use that. But for some reason, you can't use satisfy for non-characters. I get that, like, with satisfy, you have to read a bit and then, like, push it back if you don't like it. Okay, we're gonna hiding satisfy. I'm gonna write my own satisfy. Even though I only use it once. Satisfy is takes a function from A to bool and returns a parser for A, right? No, that doesn't work. It actually has to take a parser bit. Because we're okay, never mind. This is stupid. All right, we're just gonna say try. There you go. And unhide says I don't need satisfy, but I also don't need to explicitly disavow it either. And if I say this, it says, oh, I was looking for a chunk and I couldn't find it. Now it's way better. But right, so this fails, which is fine. Now I think. So now, can I just write this and it'll be fine? It is fine. Okay. So we got out 2021. And was Rubik's right? Can I not include this many bit thing? I can. Okay, cool. Great. So I think this is a momentous occasion that deserves a git commit. Day 16 can parse literals. And all we have left, why is try highlighted? Like, get out of here, LSP. All we have left is to write the subpacket parser, which is not that hard. So let's go review the spec. It is actually a little bit gross because Parsec is not designed around the idea of like letting you consume a number of input tokens and then like run a different parser over them. I don't think. I think the best way you can do it is to like consume the expected number of bits, run a new parser on it, and return that parser's result. Which, okay, whatever. So we have to parse a length type and then decide what to do. So, yeah, Rubik's I guess, like, I don't know. I don't have to repeat what's in the chat because apparently there's chat replay, but I briefly tried to do it, and I don't know. It helps if also people like who are watching aren't paying attention to the chat. For me to repeat stuff. Rubik says yes. That's what she did as well. I think it is actually the only thing you can. So let's say what is my? I need a length type. LT is from length type, which we'll have to write at some point, of course. And then case LT of num packets is great. We love num packets. Do right, because now we just parse a number. Would we parse a literal, or what's the no? If the length type, the number 11 bits that are the number of subpackets. Okay. Oh, you know what I should do? Where do I have this thing that calls 3 bits? I should. All right. Because I'm going to need to parse 11 bits, and I'm going to have to also parse 15 bits, and they're all basically the same as this, right? Fixed width binary takes an int and returns a parser for int. Fixed width binary of n equals from binary of replicate n bit, right? And so then we can say f over fixed width binary 3. There you go. And it almost seems now like, why exactly does 3-bit exist? I guess it's still kind of nice, right? Also, why is this highlighted? Functor law. Okay, it's confused. It's looking at an old version of the code. Numpacket, because this didn't compile, so fine. So n will be fixed width binary of, I think, 11 for if there's num packets. Yes. And then replicate n packet. Yes? Does that look okay? I think it looks fine. And instead of num packets, we have bit length. That's the gross one. So we have to these replicate n fixed width binary 15. B's replicate n bit, and then we have to parse B's basically, right? Parse with many packet nested packet, I guess we'll just call it, because I don't have any better name. B's? File? Length type isn't in scope, but that's okay. We'll do that in a minute. Length type is a parser for length type. length type is do, I guess. I would rather write this applicatively, but since we don't have satisfy, it's kind of gross to do so. B is bit, case B of 0, not 0, 0. If it's 0, then it's length in bits, bit length. 1 is num packets. Okay, now yeah. Case parse this of left e. We'll just return error e because I have no dang idea what happened if that didn't parse, and we don't really have a way to handle it. Otherwise, write p's, pure p's. We can put the pure out here, I guess. Error. What is E? It's a parse error, right? How do you turn an error into a parse error into a string? So a parse error, you're returned by parse. It's an instance of show. Okay, fine. Show E. Okay, great. So this all compiles. Is it woefully wrong? Let's find out. So we have an example input with 2 subpackets. So let's test that in GCI, shall we? There you go. It looks good. So version 1, packet type 6. So will it tell me? Okay. The first packet is a literal of 10, and the second is a literal of 20. So that's what we should get. Is that what we got? The version 1 operator packet containing 2 packets, version 6 literal 10, version 2 literal 20. Cool. That seems good. Let's try one more of their examples. An operator with 3 subpackets. Actually, let's look through these examples. Are any of them interesting? Yeah. I know it's right. I'm looking at the input. I'm looking. I want to make sure I run through some other examples. Just to make sure we're. I could just run it, but like I don't know. I want to just look at some simple cases before we start running on the big one. And this parse is fine as well. That's very nice. And this is a. I actually, right, my output doesn't tell me what kind of type these are. So this is 1, and this is supposed to be the same structure, but using the other length type. And these look like they produced exactly the same values. Great. Okay. So I'm reasonably content that it seems to work for, oh, sorry, you guys can't see that. I parsed both of those and they came out fine. So I think we can finally still highlighting show. Who knows why? So our input, of course, is not a list of string, right? It is a list. I don't think it should be a list of bit either. I think it should be a packet. And so we have to write a prepare function that parses a packet. but that's pretty simple, right? Case. Well, let's just put the case in a minute. We have to first strip off the trailing new lines. So let's say, oh, I bet this is where Rubik's made that mistake, eh? You tried like is digit, you filtered is digit on the input, and it threw out all the hex characters or something, the letter characters. So map, flat map of hex to bits, filter not equal new line. Text. So case parse packet standard in of that of left E error of show E right P. So that parses or compiles. So I guess what we can do then is just confirm that that works on the input. Prepare of read file input.txt. Yeah, looks good. I mean, who can say if this is right, but it parsed, so it would be a surprise if it were wrong. And now we just need to write part 1. We need an int out of this. I mean, really, I guess it should be a version ID, right? Version ID. No, does it really mean something to add version IDs? Who knows? We're going to do it rather than converting each version ID to int and then adding ints. Part 1 of I guess we're just going to. So a packet containing versioned. All right. Part 1 of packet of versioned v on and no, not contents. Yeah, it's fine. Version v contents equals v plus case contents of versioined? Not quite. So I have a packet is a versioned packet contents, which is either literal or operator. Okay. Literal packet 0. We don't care at all about the contents of a literal packet here. And if it's an operator packet of type, which we don't care about, and sub packets, it's some map part 1 sub packets. Oh, I always forget you have to use arrows for case. Okay, let's give it a try. Stack run. $866. That seems plausible. Add up the version numbers in all packets. That's the right answer. Okay, no problem. Git commit dot day 16 part 1. So now we have to learn how to write this other fold that's going to apply operators somehow. Some product minimum greater less. Okay, yeah. So this seems simple enough. Packets always have exactly 2 subpackets. All right. Equal, sure. So we can just write a couple of new things. This should be pretty simple. I'm always torn on whether to put the stuff for part 2 above, like the type part 1 and part 2, or to put it in between part 1 and part 2. I don't know. So let's say we variadic takes a function from list of int and returns a function that handles, takes a function from list of int to int, I guess, and returns a function from list of packet to int. I think it's a little bit clearer to put parents here, even though they're redundant. Am I misguided here? This seems like the kind of thing that ought to just be a catamorphism, right? Like, why am I writing this? Yeah, we're starting part 2. Part 1 was finished. It worked fine on the first try. You know, it would be kind of nice, yeah, to write this as a catamorphism. And recursion schemes can do that. I guess I need to, like, I mean, it should be at least interesting to try. Because yeah, I just have a simple function that like takes a packet. I have to put like type parameters everywhere, right? Type packet of A, and this will need an A as well. Packet contents of A is either a literal packet of A, maybe we could call a value packet, or an operator packet that contains a list of packet of A, right? I guess those are the only A's I need to throw in. Okay. And at some point I want to derive the base functor for packet and packet contents, sort of. I don't remember. I'll have to look in the documentation for recursion schemes to get it to write kata for me. let's do that now. So recursion schemes, yes. Another example, okay, yeah, so we could use data functor base, but I have my own functor, so I don't want to do that. Types with many constructors, okay, yes. Make base functor. So my first question is, does expr have to actually be a functor? No. Okay. But we need all of these things. Oh. I've now pasted those in. You guys can't see me pasting it in, but it's fine because I just pasted that. And then we can make base functor. I think packet is the only one we need, right? Or is it? Because I don't quite understand whether we need it for packet or packet contents or both. Yeah. Oh, really? It doesn't need me to parameterize it by A even? Okay, that's kind of cool. That doesn't seem right. Really? I don't... Well, maybe. Okay, so let's look more at what the heck make base functor does. Yeah, I guess that makes sense. Actually, you know what might be interesting. Is so we have here make base functor of packet. Now this is, don't I need base functor of like packet contents as well? I don't quite know. I have a catamorphism on packet, but X per F. Because what I want at some point is I want to call cata and pass it like a function of like packet contents, right? Where I'm going to look at a literal and get its value. And otherwise, it'll have already automatically recursed into the operator packet. So let's make base functor of packet contents as well, and just see what that does. All right, I haven't written variadic yet. Okay, and so what I want to do is like stack clean. Is that a thing that exists? It does. Okay. So stack build GHC options d dump splices out.hs or something. I just want to see what it's writing for me. Okay. So packet f of A, it contains versioned packet contents. So the A is like completely unused, right? And the base of packet is a packet F. Okay. Not sure what to do with that. Packet contents of A is a literal. Like, this is just... Because neither of them is actually self-recursive, the base functor doesn't do anything. Right? It only replaces self-recursion, not like co-recursion between two data types. So I don't think the base functor for this is actually useful at all. Did you actually use recursion schemes for yours, Rubix, or are you just agreeing that indeed it is a catamorphism? That in principle you could do with recursion schemes. I mean, I could have like done less co-recursive types here. Okay. I mean, I could just write it myself. It's not the end of the world. It's just like a little annoying, right? All I'm basically saving myself is like a call to map with all this garbage. It just would have been nice to have it handled for me and to understand how to do it a bit better. Yeah, I agree. It's obviously a catamorphism. But it's like a multi-type catamorphism, and I don't really know how that works. Something to research another day, perhaps. Oh, I erased too many of these. Here we go. All right. So we need like fold packet or something. Function from packet to int. Fold packet of versioned contents, case contents of literal packet P or V operator packet. I do need the number now. Op packets apply op to map fold packet packets. Oh, it's not. It's a packet of versioned contents. Okay, apply is a function from int to list of int to int. Right? Apply. Now we have to look at the definitions here. Apply 0. I guess you don't need to look at that. Apply 0 is sum, right? Apply 1 equals product. Apply 2 equals minimum. Apply 3 equals maximum. Apply 4 doesn't exist. Apply 5 is greater than, so comparison greater. Apply 6 equals comparison less than. then apply 7 equals comparison of equal, right? Where, oh no, I can't do a where. Comparison is a function from int bool to list of int to int comparison f equal ab equals case f ab of oh, I mean, I guess it's, I don't need to write a case, do I? Bool 10 of FAB, and we need to import data bool. Match expected type int with packet type on line 106. Fold packet of packets. Oh, it can't return an int. It has to. Oh yeah, it can. Oh, but these take literals. These all take literals. Ugh. Okay, that didn't fix anything. Huh? What are you upset about here? I don't understand. Oh, an op isn't an int. It's something else. It's a packet type of int. Okay, great. So part 2 produces an int, and it is just fold packet, I think. Okay. It's a number, and it looks small enough to fit in a 64-bit int, so I'm not going to worry about. Wrong answer, too high. Okay. Well, that's fine. We can debug some things now. We can test it, for example, on this. Was there overflow? I don't think so. I mean, we can check. I mentioned that I said I think it's big enough, but I mean, max bound of int is like really quite large. I guess I copied it in Emacs, which doesn't really help. I guess it doesn't prove there was no overflow. Just that if the result is smaller than max bound of int, there might have been overflow on the way. Sure. I mean, we can check real quick, I suppose, by saying returns an integer. Oh, but I have all these ints now. Okay, here's what we'll do. We'll make sure we can fit integers. Type val equal integer, and all of these are vals. Every time I see an int, I want a val, probably, right? Version ID can stay int, I guess. Packet type can stay int. Literal contains a val. From binary, I think is making an int. Oh, it sucks because I'm using it in both. Okay, this will be a val. This will be a val. Int val. Yes, replace that one. Don't replace that one, please. I thought. How do you say no? Delete works in a windowed instance, but how do you do it in a terminal? Interactively query replace. How do I use query replace? Customize responses, query replace map. Act, skip. Oh my god, there's a million of them. Skip. 78 and 110. Backspace? Okay, backspace works. We'll use backspace. Don't replace that one. Do replace that one. Do replace that one. No. Yes. No. Yes. Yes. Comparison, yeah, okay, replace those, please. No. Okay, did I break all the types? I did. Somewhere there's an int. On line 107. Apply takes an int. Packet type? Did I change packet type to be a val? I thought I didn't. I did, okay. Line 82. N is now a fixed width binary. Takes an int. I guess this needs to be a val as well, huh? Doesn't seem right. Why isn't it an int? Well, whatever. It should be okay to make it a val, I think. If that's what it says it wants. Line 82. Oh, replicate M only wants ints. Yeah, it doesn't make sense for this to... So where I'm calling fixed width binary, it's always with literal. So that's fine. That makes sense. So why... What's the type of from binary? There's a val. Like this seems right. Line 82. First argument of replicate M is a val. How did that... Oh, in here, I see. Right, because N is a val. Okay. So I guess everywhere I use... Ugh, I hate this. And I don't even think it's overflowing is what really annoys me. Is that all of this is going to not fix anything. now I have to insert somewhere like a from integer or integral call. And suddenly I won't be able to just switch val back to int and get my old code anymore. Yeah, I understand. It's this n. We're parsing a number and then using that as a call to replicate m. So I guess we can call like from integral here. I guess this will still be correct. Okay. So even if I change val back to int, I think that still compiles, right? Yes, all right. So if we run this, stack run, I think we're going to get the same value. Yeah. 7387, so that was not the problem. All right. Well, that was kind of annoying, but here we are. We ruled out one thing. Now we'll do what I kind of wanted to do before Rubik suggested there might have been an overflow, which is just like test it on some simple inputs. So part 2 prepare over this. What? Oh, right. I don't need to fmap anything. 3. Adds 1 and 2 and gets 3. This should be the product of 6 and 9. Are my greater than or less than operators the wrong way around? I think they are the right way around. Let's check. So I did check. If the value of the first is greater than the value of the second, it's 1. Oh, you know what? Maybe my call to bool is the wrong way around, though. Yeah, let's just test one of their examples that, you know, yeah, this is backwards. Ugh. I think, yeah. Okay, so it's my call to bool that's wrong. What I get for trying to use. Okay. Should be bool 0, 1. Anytime you write bool 1, 0, you should be shot. Like, puts the false before the true. Yeah. Okay. Stack. Run. Now it'll be right, and I'm like, I wasted all. But thank you for pointing that out. I was just gonna run it over all the test inputs, and we would have gotten there eventually. But you saved me some time on that. So here's my new number, please. That's the right answer. All right. So we are left then with the question: do I revert all this val nonsense? Like, because it should work with ints as well, right? So it's still correct. So we could do that. But I guess since we made ourselves flexible, we'll like leave it in. I don't know. I guess it's fine. And we have all these labels that were of questionable utility, but fine. I guess I'll leave it in. And like, this is the function that we tried to avoid having to write by using catamorphism. Like, I don't know. Every time I've used recursion schemes in practice, it's like, it's always much longer than just doing it by hand. But it is kind of nice and elegant. Okay, so we'll add that in as well. Just I don't know that it's a flawed execution of a good concept so much as like it's solving a problem that isn't really... Writing recursion by hand is not really a big deal. It doesn't feel like elegant to do, and it feels really cool that you can abstract that idea out. But in practice, like it's not hard. And so every time you use it, you end up like kind of making your program not really obviously better in any meaningful ways. Like, yes, it's nice in the same way that like it's nice to write map instead of doing recursion yourself. But I think that the savings are not as large and the cost is higher, so it doesn't really work that well. All right, and you know what? We'll just like get rid of this. I don't know, the input type. We'll just get rid of. There you go. Today we just take packets. I think this looks okay to check in now. Well, let's make sure I didn't break anything. Day 16, part 2. All right, are we going to try and do any more than that? Probably not, right? Like, day 17 is this ballistics thing. I haven't even looked at day 18. We might as well read that on camera. What are they doing on day 18? You run into snailfish. They need math homework help. Snailfish numbers are pairs. Oh, it's con cells. Okay. Yeah, fine. Add them, form a pair from the left and right. Parameters of the addition operator. Okay. Process of adding numbers. To reduce it, you do one of these two things. Oh my god, what a bizarre... Okay. If any pair is nested inside 4 pairs, what does that mean? I guess they'll show me. Oh, sorry. There you go. So if a pair is nested inside 4 pairs, okay. The leftmost such pair. So this pair is nested within these 4. The pair's left value is added to the first regular number to the left, if any. And the right value is added to the first regular number to the right. 8 gets added 1. Ugh. Exploding pairs will always consist of 2 regular numbers. Yes? So this pair basically, the 9 is not added to any. Oh, and the entire pair is replaced with 0. So we took this pair of 9, 8, and we made it 0. And this became a 1. So it's still wrapped in this pair. This 0, 9 corresponds to this. Hello, Jonathan. We finished day 16 already. I'm just looking ahead at day 18 to see what's going on. To split it, you replace it with a pair. Okay, that's easy. The number that remains is the actual result of the addition. Sailfish numbers are listed on separate lines. Add the first and the second, and add that to the third, and so on. How do you add? You. So addition is just writing them next to each other? Yeah. Check whether it's the right answer. They check the magnitude of the final sum. Okay, whatever. Magnitude is easy to compute. Oh. It's interesting. Finding the places to explode and where to put them is like kind of a thing. So to split, you replace it with a pair. That's easy. So exploding, I think, is the only interesting part of this problem. How do you find the leftmost thing that's nested within something while still having good context? Well, if it's nested within 3 things, one of them will definitely be the top level. And so you can just look within the pairs that are at the pair that's at the top level and search it for things that are nested 3 deep. One of which will be, well, yeah, and you can, okay, I don't know. So I have some ideas, but I'm not gonna like start working on this now. It's late enough. I'm gonna call it a night. This time Jonathan arrived just at the end. There was a stream a couple days ago, or I don't know, sometime last week maybe. Rubik's arrived right as we were finishing, so this time it's your turn, Jonathan. We can do a quick survey, I guess, or review of what we ended up implementing, which was like, hey, some cool types here, right? 7 types that define packet. And you know, one thing we didn't end up needing at it was we didn't use chart a bit because it was only defined for testing and GHCI, so we can get rid of that. But folding a packet was really easy, and I guess I could have just written it in part 2, huh? Same way I inline something to part 1. And this table of operations is very simple. So obviously the parser was like most of the interesting work. But I think it's fairly simple to write parsers in Haskell. Like you just kind of break it apart into meaningful sub pieces. Maybe next time I'll try Mega Parsec because apparently it has satisfy for for primitives. Okay, anyway, I think I'm gonna get out of here. Hope you guys enjoyed. Thanks for watching. I don't know when I'm doing the next one. Probably sometime this weekend, but we'll see whether. I mean, I'm busy most of the day Saturday, but I get back in the evenings, and it's like whether I'm tired enough that I want to go to bed or. Well, what? Not. I get back like 8:30. I'm not going to bed at 8:30. Whether I just want to relax or do some Advent of Code, we'll see. So, but I'm sure I'll see you for more Advent of Code eventually. Maybe I can stretch it out through the whole month of December and then some. It'll be a Christmas miracle. All right. Yeah. Thanks for watching, and I'll see you next.